Welcome to this presentation. Thank you for your attention. So I'm going to talk about automated documentation for open source hardware. This is joint work with my colleague JC, who is upstairs moderating a session. I'm presenting this to you. So let me immediately discuss the goal of what our research. It's a research project, and the goal of our research project is to automatically generate IKEA-style assembly instructions for open source hardware. Let me try to find a position not in the light. It's difficult. So IKEA-style assembly instructions for open source hardware. So let's first start with open source hardware. I think everybody now has a feeling of what it is. And I think the best example here is the Openlab Starter Kit, mentioned already. And here you can see three machines. At the left, the Fabulator, I'm just going to stand here. The Fabulator Mini on the left, and a CNC mill, and then a 3D printer. And at the right, you can see us assembling a Fabulator Mini. And all three machines are actually featured in the microfactory. And the ideas for the Openlab Starter Kit project is to create 8 such machines and 3 versions for each of those machines. And you can see in the microfactory, you can see already a new iteration of the Fabulator Mini. So that's also very interesting. This is the old version. So, and then I talked, of course, about automated documentation. So why automating the documentation? Well, if you think about it, open source hardware, documentation is really crucial for open source hardware. If there is no documentation, you cannot replicate the machine. So it's really crucial. But it's not only necessary for replication. Collaboration is also a big part of it. So the documentation allows you to understand the design philosophy, for example, and build upon it and create a new version or improve small things. However, as everybody knows, creating high quality documentation is very labor intensive. And in this highly collaborative environment, documentation tends to be always out of date. And that is, of course, a limitation to collaborate and replicate. So many people recognize this problem and have been working on that. And there are generally 2 approaches to documentation. Is after the fact. So you design a machine and then you document. And this is, I think, typically what a company would do. But for open source hardware, document while doing is more a better approach. You document while you're doing. And in essence, open source hardware is always in development. So. And the current state of art is something that Git building. It's more text-oriented than our approach, but we feel that it lacks a semantic relation between the source, the CAD computer-aided design files, and the documentation. And that's what we're trying to improve on, and we're much more visually oriented. So our goal is to also step away from documenting after the fact or document while doing. We basically want to integrate the design process with the documentation process. And then, of course, that we want to generate those assembly instructions. That is what we are focusing on automatically. And to support documentation for design evolution. When the design evolves, the documentation should remain up to date. That is our goal, essentially. So the Fabulation Manual is our starting point. So the Fabulator Mini laser cutter, 3 persons in Daniele Ingressia's company have been working very hard over multiple months to create very high quality, a very high quality assembly manual that you can see here on the right side. And you can see it's IKEA style. This is a very beautiful manual, and we use it to build such a machine, but it had one problem. if the design changes, it's very difficult to incorporate this into a new manual. It's easy to make mistakes. For example, all the screws that are used in this particular assembly step are counted manually and then mentioned in the top left. It's mentioned here, but it's counted by hand. And of course, this requires lots of discipline to keep this always up to date, and that's a problem. So what is the approach that we take, the overview? So we are staying close to the design files, computer-aided design files. We take those CAD files, we take a textual specification, and we use both streams of information, essentially, to automatically generate documentation. And we try to get close to the original manual. So we created software for that. Here we see the open source hardware automated documentation Workbench. It's a plugin for FreeCAD open source software, and we extended it basically for documentation purposes. And here you can see that we took one. We moved to a specific corner, and you can see, for example, those red lines for the screws, and we can automatically click on such a screw, and then it pulls it out just for being used in a manual, and this is done automatically. And I want you to focus on this little thing that is selected, step 1 detail. So this is one of the details that we want to show in the manual. And this string of characters, this is what we use to create kind of a semantic relation between the textual specification and the CAD file. For documentation purposes. It will become clear in the next slide. So here at the left we have the textual specification, and together with the CAD file, this is enough to create the page that you see on the right. And so, for example, we specify that the step is called building the bottom frame, and this gets reflected at the top in the manual. It has a command that we call mini-BOM, bill of materials. So it will automatically create the left column here that is highlighted green based on this information. Then we incorporate the main image of the manual. We just have to specify this string of characters, step 1, and this gets incorporated into the manual automatically. And here we see the highlight that you saw in the previous CAD file. And this is this string that I asked you to focus on, step 1 detail, and this is how we create those semantic links, and that is true for all the red underlined strings here. So this is how we create a semantic relation between the CAD file and the documentation. And this is, I think, the novelty of our work. And then, of course, we support also the remarks and the tools. And so simply from this small textual specification, we generate this page in the manual. So, comparison to original. So this is an exercise for you. Please spot the differences. If you do, free drink at the bar. And so, no, but here we can, so there are some small differences, but we really succeeded to get close to the original manual. I see some puzzled. Yeah, what are those differences? The dots, yes, so let's zoom in. So here the red dots sticker, so that one, and used here in the text, that's a little bit difficult for us in our software to be able to insert a red circle in the text. So we are not as flexible as a designer, graphic designer that does this automatically, manually, places all these things manually onto the page. But minor things, I would say. This is for another step, also very close. Small difference is that when you manually set up this page, you have a little bit more flexibility in using two tools for, small things. But we got very close to the original manual. So, and indication of time is, so this is really academic work, scientific work, but we cannot claim that we are so much faster because we don't know about the baseline. So the original manual has been developed over multiple iterations, many months, so it's difficult to say. But what we could do is take a small machine, a vise, consists of 6 steps, and once you know which steps you want to have in your assembly manual, it takes only 24 minutes to set up a pretty high quality manual. And we also tried it with a vertical lathe, 5 steps, 26 minutes. Let's say an hour, in the order of hours for 5 steps. I think that's, yeah, I'm pretty happy with that result. Design evolution. So when you want to go from version N to N+1, the next version. So minor changes in the design. So suppose you replace screws with different screws. Essentially don't require any action at all. You just press a button, new manual gets generated automatically. If the change, suppose you make bigger changes, so you replace a part that is much bigger, for example, then it requires more actions. And the biggest change would be if you, for example, decide to split a step into 2 steps, for example. But even then, because of the abstractions that we used in this documentation workbench, the scope of where you have to adapt things is very limited to about 5 places or so in the software. So this is a moment where I really want to acknowledge Daniele Ingrescia, who is working on the Openlab Starter Kit. He worked together with a CAD expert, Mark Colin, and a graphic designer, Liana Honda, and they created this great manual for us that basically was the starting point, the inspiration for us to trying to generate this automatically. So thank you for that. Yeah, so let me finish up. So automated documentation. So our research proposes a novel solution to what we call the documentation problem in the collaborative environment of open source hardware. So I just want to give you a gist of what we did, and yeah, if there are any questions, feel free to post them.